Those white clouds that you see coming out of the rocket are due to venting of the chilled gas from the rocket into the humid Florida air out here. That's why the gas condenses into
Those white
vapor and
clouds that
looks
you
like
see coming
clouds
out
when
of the
it's coming
rocket
out.
are due to venting of the chilled gas from the rocket into the humid Florida air out here. That's why the gas condenses into vapor and looks like clouds when it's coming out.
For those just joining us, we are at T minus 20 right now, and we're actually holding the clock due to upper level winds. The team is currently
For
evaluating
those
this and will
just
provide an
joining
update as
us,
soon as they
we
have
are
it.
at
However,
T
the
minus
vehicle is
20 right
healthy and
now,
the
and we're
range is
actually
currently
holding the
green. So as
clock
soon
due
as
to
those
upper
upper
level
level
winds.
winds
The team
slow
is
down a
currently
little bit,
evaluating
we'll
this
be
and
able
will
to
provide
provide
an
another
update
update.
as soon as they have it. However, the vehicle is healthy and the range is currently green, so as soon as those upper level winds slow down a little bit, we'll be able to provide an update.
For those just tuning in, we did hold the clock at T minus 20 minutes today, but we're expecting a briefing in the next 5 to 10 minutes on what's happening with the upper level winds that were the reason for us holding the clock. We'll continue listening in and hopefully everything sounds good.
Briefing in the next 5 to 10 minutes on what's happening with the upper level winds that were the reason for us holding the clock. We'll continue listening in and hopefully everything sounds good.
For those just tuning in, we once again held the clock at T minus 20 minutes due to weather issues. Unfortunately, upper level winds are
For
currently
those just
marginal, so
tuning
the
in,
team is
we once again
evaluating
held
live
the
data
clock at
to
T
determine if
minus
we can go
20
ahead and
minutes
keep rolling the
due
clock
to
or if we need to
weather
pause for a
issues.
little bit longer.
Unfortunately, upper level
And as we
winds
wait
are
on that
currently marginal,
additional
so the
data
team
on
is
the upper level
evaluating
winds,
live
and
data
as we get
to
an
determine
update
if
from
we
the
can go
team,
ahead
let's
and
go ahead
keep
and take a
rolling the clock
moment
or if we
to
need to
get
pause for a
an
little bit
idea
longer.
about all the work that the And as integrated we wait on performance that team does additional for data on Relativity the upper Space. level winds, and as we get an update from the team, let's go ahead and take a moment to
Hi,
get
I'm Ryan
an
Kraft.
idea
I'm
about
Katie
all the
Wallace.
work
My name is David Brown,
I'm the Director of Integrated Performance at Relativity.
I'm a vehicle simulation engineer.
and I'm a staff vehicle simulation engineer.
One of the key things that we focus on in the department is connecting all the different teams, making sure the structures work with the engines work with the software, and the software works with the electronics hardware. I was lucky enough to work in a few different hardware startups. This is actually number 5 for me.
1 cell for Aeon R engine tests. On top of that, we're building out an additional 150 acres for the Terran R program, and we've already started construction on the new engine test stands. Other structures there will include a full-scale second engine stand, office buildings, and of course an integration hangar. All the structures we're completing out there are built from the ground up on previously unused land. After testing, we ship the components to the launch site. We of course have our operation. In 2019, we secured a direct agreement from the U.S. Space Force for Launch Complex 16. And Relativity joins just a few others here as only the 4th company with a currently operational orbital launch site at Cape Canaveral. Both Terran 1 and Terran R will launch from Launch Complex 16. With that, we are now approximately 27 minutes away from launch.
This is so exciting. I hope we continue to move forward, but just as a reminder, we do not have a customer payload on board, but we do have a memento in the nose cone. We have included our first ever 3D printed piece from our Stargate printer. Of course, it was a failed print since no one had done it before. Let's go ahead and take a look at this memento. So that piece that you see there is 6.5 inches in diameter and weighs about 3 pounds. It is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we've added a machined centerpiece with a GLHF for good luck, have fun, and our mitosis logo to commemorate this maiden launch.
And from our very first failed print 7 years ago, it's taken a relentless focus on innovation and almost countless iterations to get to where we are today. The world's first 3D printed rocket on the launch pad here at Cape Canaveral. Like the first print, Terran 1 is the first step of many towards making humanity a multi-planetary species. As a reminder, our primary objective for today is to gather as much data as possible to help develop our future vehicles, including Terran R, our larger medium to heavy lift reusable launch vehicle. Now we're currently at T-minus 25 minutes. We're going to continue standing by for further updates from Mission Control. Medium to heavy lift reusable launch vehicle. Now we're currently at T-minus 25 minutes. We're going to continue standing by for further updates from Mission Control.
All parties all met. situational briefing for pre-go, no-go. All parties be aware the go, no-go poll will be performed in approximately 10 minutes. Primary test objective is a transition into countdown through terminal startup and release into flight. Vehicle status, propellant is loaded. We are tracking no additional items for constraints. And while we are still waiting on one final balloon, we are still a go unless that balloon comes back as negative. For constraints. All assets are standing by for launch. We will do polls in approximately 6 minutes. Stand by all parties. All assets are standing by for launch. We will do polls in approximately 6 minutes. Stand by all
And you
parties.
just heard that situational briefing from Clay Walker. The vehicle is very healthy right now, and the only issue that we're tracking is unfortunately the weather. But we are awaiting data, the latest data from our weather balloon to determine if we can continue and go ahead with our scheduled launch time of 14:35 Eastern.
But we are awaiting data, the latest data from our weather balloon to determine if we can continue and go ahead with our
As we
scheduled
continue
launch
to
time
wait,
of
maybe let's do a recap on
14:35
the Terran
Eastern.
1 architecture and go ahead and look at this graphic of our Terran 1 architecture. As a reminder, Terran 1 is 110 feet tall and 7.5 feet in diameter. We have 2 stages that are expendable. On the bottom, we have 9 Aeon 1 engines. Each has a thrust capability of about 23,000 pounds at sea level, giving us a max total liftoff of more than 200,000 pounds. The Aeon 1 engine is designed with a gas generator cycle, and as you previously heard, we have thrust vector control actuators, or TVCAs, on the engines that allow us to gimbal during flight. We have completed more than 2,000 engine hot fires as we prepared going into launch today. The Aeon 1 engines are attached to the vehicle through a thrust structure, and above the thrust structure we have WAM printed tanks. Arwa previously shared that this is the wire arc additive manufacturing in-house process that we use. And these tanks hold liquid oxygen on top and liquid natural gas on the bottom. During flight, we pressurize our tanks using an autogenous pressurization system. This means that we tap some propellant from the engines, and this is run through heat exchangers mounted on those engines and converts the liquid propellant into a gaseous state, and we pipe it back to the top to maintain the required tank pressure or ullage pressure. Above the stage 1 tanks, we have a WAM printed interstage, which holds our stage separation mechanisms. This is what we use to separate stage 2 from stage 1 during flight. The stage separation system uses pneumatic pushers. And above the interstage is stage 2, which has a single Aeon vacuum engine. This engine has a thrust capability of more than 25,000 pounds in vacuum and has the capability of multiple restarts. Stage 2 is also WAM printed just like stage 1. And above stage 2 is our WAM printed nose cone, which we just shared about the memento inside of that nose cone. For future missions, we will replace this nose cone with a fairing and also include a fairing separation system. Terran 1 was designed with a payload capacity of 1,250 kilograms to LEO or 900 kilograms to Sun Synchronous Orbit or SSO. All the data from today's launch and Terran 1 development will be fed into Terran R. But note that
It's 2 NRC RCS checkout complete.
we're going to go ahead and pause and listen in on mission control for any more updates. Thank you.
As of now, it seems like everything is on track, and we're going to perform the go, no-go polls in just a few minutes here. So we're going to stand by to listen into mission control.
Copy. All parties on all nets, this is the go, no-go for launch. Please provide concurrence to proceed into launch with launch countdown go, no-go. VC. VC go. VC go. GC1. GC go. GC go. GC2.
GC2 go.
GC2 go. Ground. Ground go. Ground go. AVI. AVI go. AVI go. FTS.
FTS go.
FTS go. RF. RF go. RF is go. GNC. GNC go. GNC go. Flight software. Flight software go. Flight software's go. Prop 1.
Prop 1 go.
Prop 1's go. Prop 2. Prop 2 go. Prop 2 go. Fluids 1. Fluids 1 go. Fluids 1's go. Fluids 2. Fluids 2 go. Loads. Loads go. Loads is go. Rock.
Ranges go.
Ranges go. OSM.
OSM is go.
OSM is go. RC.
RC go.
RC go. Vehicle.
Vehicle is go.
Vehicles go. CE.
CE's go.
C's go. LC.
LC is go.
LC is go. All parties have reported go for launch countdown. Once the clock begins to roll, anyone can call for a hold at any time. If a hold is called prior to T-minus 70 seconds, the T-clock will continue to roll until T-minus 70 seconds, at which point a hold will be automatically initiated. A hold is not possible after T-minus 70 seconds, and any hold call after that time will result in a terminal count abort. Should a hold or a manual abort be necessary, the person calling for a hold or abort should state clearly on comms, hold, 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 or abort, abort, abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify the LD and the RC on the primary net.
And you just heard our launch director complete the go, no-go polling with our mission control team. As you heard, all systems are currently healthy, so as of now, we're able to proceed with our scheduled launch time in just about 13 minutes.
Throughout today's live stream, you've been hearing callouts from Mission Control. Now let's take a moment to introduce you to our Mission Control team. As you just heard, Clay Walker, Launch Director, John Wiswall, Launch Conductor, James Harris, Chief Engineer, Elijah Escobedo and Zoe Dickert on Vehicle Controls, Brian Vatters, ground control. Bill Stack, ground. Joy Mosdell, range control. We also have a few notable members of leadership supporting today's launch, and they are also here at Launch Control with us. This includes our co-founder and CEO, Tim Ellis, our Chief Operating Officer who leads product execution, Zach Dunn, Vice President of Test and Launch, Don Katterbeck, and Director of Cape Operations, Pat Zvatek. These are among many, many others who are making today's launch happen. Let's go ahead and take a moment to wait as we get more updates from Mission Control.
For those curious, you'll be able to see small white pieces falling off the rocket. Not to worry, that is just ice falling off from the frost on the vehicle due to the chilled propellant inside. On the other view, you might have also seen a small flame to the far left of the view, and that is just the flare stack that's used to burn off any flammable gases from propellant loading and venting operations. Once again, those white clouds you see coming out of the rocket are due to the venting of the chilled gas from the vehicle into the humid Florida air out here. That's why the gas condenses into vapor and looks like clouds. In just about 46 seconds here, we will begin our countdown sequence.
T-minus 10 minutes, countdown sequence has started.
And we're currently at T-minus 9 minutes and 45 seconds. In the upcoming minutes, you're going to hear several call-outs from Mission Control as we go through the final pre-launch procedural steps, including the priming of the igniters, final engine checkouts, transporter erector retraction, and getting that final go for launch. Again, we're now pressing the tanks to flight pressures, as you just heard, and we're currently proceeding with our scheduled launch time. In just about 30 seconds, we'll be transitioning stage 1 to helium. And I'm receiving an update here. We just got the data from our latest weather balloon, and we are a go with upper level winds. The weather isn't stopping us today.
Stage 1 pneumatics have transitioned to helium.
And that means we're pressurizing the propellant tanks to flight pressures with helium. As a reminder, during
Tanks are
flight,
pressing for engine chill.
we'll pressurize the tanks with autogenous pressurization. That last call out was that we're pressurizing the tanks for engine chill.
We're now getting into the business end of today's countdown. Let's take a moment to walk through the launch timeline.
At T-minus 3 minutes, the transporter erector, or that black truss structure, will retract just a few degrees to give the proper angle for umbilical separation. At this point, the vehicle will be on internal power. Then at T-minus 70 seconds, the vehicle will go into terminal count. This is again when the vehicle's internal flight computer takes control of the countdown. And we then go into final flight termination
Stage
checks
2 igniters and flight targets.
and get FTS go from the launch conductor in coordination with the mission flight control officer and operations safety manager. At T-minus 6 seconds, we'll have ignition of those 9 beautiful 3D printed Aeon 1 engines, so you'll see the flames beneath the rocket at that point. And at T0, we will have liftoff. Shortly after that, at T+2 seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly. At T+12 seconds, we'll begin our pitch over program, and at T+80 seconds is that important milestone of max Q, or the point of maximum dynamic pressure. This is again where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight.
At approximately T plus 160 seconds, we will get to main engine cutoff, or MECO. This is when the stage 1 engines will shut off. This will be followed shortly by stage separation and ignition of the Aeon vacuum engine. Second stage will burn for a little under 5 minutes. And then at approximately T plus 463 seconds, we'll have second engine cutoff, or SECO. As a reminder, we do not have a fairing or any payload deployments for today's first launch. We'll go ahead and continue listening in on mission control.
We're currently priming the igniters with gaseous oxygen and gaseous hydrogen. Our ignition system uses these propellants flowing across the glow plug.
Stage 1 igniters priming in.
Stage 2 igniters and final press.
As a reminder, GLHF is our maiden launch, so while a nominal flight would have Terran 1 reach orbit today, our primary goal is to learn as much as we can and demonstrate the product concept. A major milestone would be to have Terran 1 make it through max Q, the point of maximum dynamic pressure.
Stage 2 is on internal power.
And you'll now see those cradle arms are slowly starting to release stage 2 at the top there so that the strong back can retract.
Stage 1 TVC checkouts.
Over the next minute and a half, we'll be performing the final thrust vector control health checks on both stages before liftoff. You'll be able to see the engines gimbaling or tilting if we're in that engine view. There we go.
Stage 1 is on internal power. Strong back retracting.
And now that black truss structure behind the vehicle will retract just a few degrees to prepare for umbilical separation.
Stage 2 TC checkups.
As we approach T-minus 2 minutes, what you're looking at on your screen is a vehicle that is 85% 3D printed, and it is about to fly. Next up, our range coordinator will ask the range for their final green status.
Hold. Is the MIFCA will hold due to a fouled range.
You heard that call out. Someone is calling a hold due to the range. We're going to stand by for updates. There appears that there may be a vessel within our clear radius. We're going to stand by to hear confirmation from the range. And I just got confirmation there is a boat in the range. We're going to stand by to see if they can clear the boat from our radius. Once again, just to clarify, our vehicle is healthy and all systems appear to be performing nominal. We just got to go for the weather for upper level winds, but unfortunately there's currently a boat in the range, so we're just awaiting confirmation to see if they can clear that boat in time and get it out of our radius.
Announcement on countdown net is the LD. We got a hold called prior to terminal count. Hold gating items have been cleared. We are adjusting for a new T0 time. We'll hold the clock for terminal count until we pick up the count.
All right, now we are just confirming a new launch time. All items that were blocking us and giving us a red range have now been cleared out. So we're going to await that updated launch time and then update the T clock above as necessary. All right, and the clock is about to resume just shortly here. They are coordinating that new T0. We're very excited to get this thing
Announcement
going.
on countdown net. T clock should pick up in 60 seconds.
60 seconds. We have confirmed our new T0 is going to be 14:42 Eastern. Once again, that's 14:42. We'll see the T clock rolling in just a moment here.
T clock's rolling. Terminal count.
Colin Dalton, close out.
Flight computer and countdown.
T-minus 60. GCU with the count. LD, are you go for launch? LD is go for launch.
And we just got that final go for launch from our launch director. We are now just about...
Range green.
Range is green. We're now about 30 seconds away from the moment that we've all worked so hard for our first launch. We've had a lot of fun with you, Terran 1. Good luck. And here we go.
10, 9,
as you can see, we had ignition of our engines, but the T-clock did hold at T0. We're going to stand by for updates. All right, I'm hearing from Mission Control that we're currently assessing vehicle health to confirm if we can do a recycle today and try this thing one more time.
Announcement on countdown net. This is the LD. The aborted terminal count on a launch commit criteria violation at T-minus 0.5 seconds prior to liftoff. Are safing the vehicle and assessing recycle opportunities.
As you heard, once again, we had a violation with our launch commit criteria, which is why we had an abort shortly before liftoff. The team is continuing to assess vehicle health to confirm if we can have a recycle today. As a reminder, we're currently at 1450 Eastern Time, and our launch window is open until 1600 Eastern. So our teams are currently assessing any recycle opportunities that we have during this time. You'll see an occasional cloud coming out of the transporter erector or the black truss structure there. That is just because we're creeping our propellant topped in case we can reattempt a launch before the end of the window today at 4 p.m. Eastern. As you can see, the T clock rolled back. We are still working on a recycle, so we'll keep you updated as soon as we have confirmation. All right, the T clock is rolling again, everyone. We just have an updated launch time of 15:55 Eastern. Once again, 15:55 Eastern in just under 44 minutes. We're going to keep going. I just got an update from our engineers in mission control. We are updating the T0 time to 1600 Eastern. Once again, that is 1600 Eastern. T clock is rolling.
For those of you that are tuning in today, we're going to take a moment again to introduce ourselves. My name is Rachelle Aniceto. I am the Chief of Staff for the Vehicle Architecture and Technology team.
And I'm Arwa Tazani Kelly, Technical Program Manager for Test and Launch here at Relativity Space. Now, ahead of Terran 1's liftoff, we invited some of the most influential voices in the space industry to curate some questions from you all on Twitter about our journey to launch. We appreciate the time that Michael Sheets, space reporter at CNBC, Eric Berger, senior space editor at Ars Technica, and Tim Dodd, the everyday astronaut, took to answer your questions. Let's take a look.
This question comes off of Twitter from Danny Stover. Many launch companies fail their first attempt. Will Terran 1 reach the same fate? What makes Relativity's approach different? I want to hear, Michael, what do you have for that one?
Many companies failing their first launch attempt is, I think, a great example of the high risk aspect of the development process. And I think that's one thing a lot of people need to keep in mind is there's along the way to development, even before launch, there's all these milestones that you're trying to get through, including, as we've seen recently, static fire. So you pass those milestones, you get more data. As you move closer and closer, the end goal is, can we not just get into space, not just get into orbit, but deliver into the targeted orbit, get to the place we want to actually be? And I think a nice analogy of it is like ordering an Uber. You want an Uber that's going to get you the closest to your destination, ideally your front door. But if your Uber is dropping you off, a couple miles away, you're probably not going to continue, using the app anymore because you're going to try to go with a competitor who's actually getting into that ideal orbit. So will it make its first attempt is that open question. And I think I really want to stress the development side of where the company is, because people see failure at kind of any stage and they go, oh, this is a wash. But it's really important to understand that ultimate goal of an intentional specific orbit.
I'll answer the question a little bit more bluntly. I do think Relativity probably will fail on their first launch attempt. If you look back at no new space company has ever reached orbit on their first flight attempt. You had Rocket Lab fail, SpaceX failed on their first attempt, Virgin Orbit failed, Firefly failed, ABL failed. And so, it's the odds are against them, and more credit to them if they succeed. And I also think that the 3D printed nature of the structure is a big test. Are you going to be able to see that get through max Q? And then there's some more complex elements on the Terran 1 rocket that you might see in a more traditionally developed launch vehicle. And so I think seeing a nominal first stage performance would be a pretty big win for Relativity. And I'd love to see them get to orbit on their first time out. I just think historically the odds are pretty long against it.
Yeah, I'm definitely with Eric there. I realized just recently that, the Pegasus, when it first launched, was one of the only rockets to successfully make it to orbit on its first launch. So, that was definitely not by any means considered new space by today's standards. But realistically, like Eric said, the odds of being completely successful on the first round is statistically about zero. So I'm just excited to see if they can get through the first big milestone. If they can, make it through max Q, if they can see stage separation. Each staging event is definitely one of those big unknowns until you do it for the first time. Can you light your upper stage engine? Can you, deploy your fairing? Can you eventually, if you get to deploying a spacecraft from, on orbit, that's the ultimate milestone, of course. But yeah, there's a lot of things between there and leaving the ground. So yeah, time will tell.
I mean, I think only of the companies that we talked about outside of Pegasus, and that was Orbital Sciences, and of course that was a solid fueled rocket, and most of which was not developed in-house like the commercial space companies of today. But of the companies we talked about, only Rocket Lab got to like a second stage engine ignition and flight, right, on their first mission.
Yeah.
21st century wise, that's definitely true. And I think another way to tackle this question is defining failure, because when you talk about many companies fail their first attempt, you need to understand the multi-step process of a rocket launch. And I think that's another important aspect where, depending on how far they get towards their ultimate goal, will categorize whether this is a learning experience from a failure standpoint, or this has a lot more to build upon. And every step that they complete during the launch is another check mark towards success.
Yeah, absolutely.
This next question comes from Hantronics. With the capability of 3D rocket printing, will we see a day when rocket engines are a part of the ship structure such that their major components won't need to be removed, inspected, or replaced after every launch? I don't remove my engine in the car every 1,000 miles.
I think there's always going to need to be some kind of repairability and separateness of the components of the structure of the vehicle and the engines. I mean, there's just an inherent, physical moving parts. You have bearings, you have valves, you have components that just would need to be inspected on any vehicle. And if you completely integrate that into the structure to the point of not being able to remove and service it, you just really, you really limit yourself. Now, if you're talking about an expendable launch vehicle, there is the potential that integrating it could actually add potentially some reliability or simplicity or mass saving. So it depends on your overall goal. If you're talking about a reusable vehicle that you're flying over and over and over, completely integrating it to the point of not being able to even remove and service it is probably not the best idea, in my opinion.
I would just say that, this is an impossible question to answer now because we have to see if 3D printed rockets are capable of flying. And that's the great thing. What I love about the launch industry today is you've got all these companies trying different things, right? You've got ABL out there trying to basically build a miniature Falcon 9 as simple as possible, a modular approach, ship it and shoot it from a launch pad. You have, Virgin Orbit trying air launch. You had Astra trying to build the cheapest, perhaps less reliable rocket, and you got Relativity doing additive manufacturing. And so it's great to see all of these different approaches because we're going to try them all out, and it takes a real world test, I think, to get the right answer ultimately.
I'll do this one. This one comes from Kyle A. Mabe asking, what other markets in the space sector or beyond do you see Stargate technology being applied in? I kind of mentioned it earlier. I would love to see, large scale additive manufacturing be used for, automobile prototyping, race car prototyping, especially. Oh my God, like the Formula One world where every year the cars have new restrictions and new rules and a new, set of rules to have to engineer by. Being able to at scale develop stuff with a 3D printer makes all the sense in the world. So I think that's a pretty no-brainer would be the automotive industry.
I think there certainly are potential other market use cases, but additive manufacturing, obviously predated Relativity, and they're trying to apply it in this really significant way with such enormous structures. And I think that's the fascinating aspect is you try out the technology behind the rocket in such a extreme use case where then other sectors can look, where can we apply this? Where can we iterate faster by implementing printing these as solid entire structures as opposed to different pieces that you put into whether it's for shipping or other large industrial components. You can see the kind of downstream effects of basically a demonstration of, hey, we can build a rocket with this type of technology. What else can't we build?
I think Michael's exactly right. There's been talk about Relativity since it was almost since it was founded. Is this a launch company or is this a 3D printing company? I think, that once they sort of wrap their hands around spaceflight, they're going to be taking this technology into other areas. And we don't really know what those are. It'd be interesting to find out. Just for me personally, one of the big issues that we've seen in this country and around the world has been housing issues. And so I don't know if 3D printing these large structures could be applied to housing units or things like that. But it's going to be fun to find out where this technology goes.
That was a great video answering some of your questions on Twitter. Now we are at T minus less than 30 minutes from our launch with our updated launch T0 time of 4 o'clock p.m. Eastern. So that is 1600 Eastern. We're currently going to stand by from an update from Mission Control in the next few minutes. The go, no-go polling from Mission Control is coming up here in just a couple of minutes, around T minus 16 minutes. We're going to stand by and continue listening in, awaiting that poll.
All parties, all nets. This is the go, no-go poll for launch. Please provide concurrence for proceeding to launch operations with go, no-go. GC go. GNC. Flight software. Prop 1. Prop 2. Fluids 1. Fluids 2. Loads. Rock.
Ranges go.
OSM. RC.
RC go.
Vehicle. CE. LC. LC go. All parties are reported go for launch countdown.
All right, our team is being relentless here. We are not giving up, and we're going to give this one more shot with an instantaneous window at 1400 Eastern. As you heard, all parties have reported they are go for launch.
And just a reminder, 1600 for that launch. And as we continue to wait, let's remind you what we have inside of our nose cone. So we don't have a customer payload on board, but we do have our special memento, which is our first ever 3D printed piece from our Stargate printer. As we mentioned before, it was a failed print, but this is just special for us as we get to this moment. As a reminder, that piece is about 6.5 inches in diameter and weighs about 3 pounds, and it is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we added a machined centerpiece with GLHF and our mitosis logo to commemorate this maiden launch. We'll go ahead and tune back in to mission control and wait as we get closer and closer to launch.
T-minus 10 minutes, countdown sequence has started.
And you heard that call out. We're currently at under T-minus 10 minutes. And in the upcoming minutes, once again, you're going to hear several call outs from Mission Control as we go through the final pre-launch procedural steps, including priming of the igniters, final engine checkouts, transporter erection retraction, and getting that final go for launch for this attempt. Again, we're now pressing the tank
Going to flight targets.
to flight pressures, as you just heard, and we're currently proceeding with our time of 1600 Eastern. This will be our last attempt for today, and it is an instantaneous launch window. Stage 1 will be transitioning to helium shortly.
Stage 1 pneumatics have transitioned to helium.
Once again, that means we're pressurizing the propellant tanks to flight pressures with helium. And as a reminder, during flight, we'll be pressurizing using autogenous pressurization. Tanks are pressing for engine chill.
Since we're getting into the business end, let's remind you about our launch timeline. Arwa, take it away.
So again, at T-minus 3 minutes, the transporter erector or the black truss structure behind the vehicle is going to retract just a few degrees to give the proper angle for umbilical separation. At this point, the vehicle will of course be on internal power. At T-minus 70 seconds,
Stage 2 igniters for flight targets.
The vehicle will go into terminal count, and this is again when the vehicle's internal flight computer takes control of the countdown. We'll then go into flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operations safety manager. At T-minus 6, we're gonna see that ignition one more time of those 9 Aeon 1 engines. So you'll see the flames, the blue fire, I should say, beneath the rocket.
Stage 2 igniters priming in.
And at T0, we'll have liftoff. At T plus 2 seconds, the strong back is going to throw back to remove the umbilicals and clear the path for the vehicle to fly. At T plus 12 seconds, we'll begin our pitch over program. And then at T plus 80 seconds, we're going to reach max Q, or the point of maximum dynamic pressure. This is again where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight.
At approximately T plus 160 seconds, we will get to main engine cutoff. That is where the stage 1 engines will shut off, and it will be followed shortly by stage separation and Aeon vacuum engine ignition. Our second stage will burn for a little under 5 minutes. Then at approximately T plus 463 seconds, we'll get to second engine cutoff when that Aeon vacuum engine will shut off. And as a reminder, we do not have a fairing or any payload deployment
going across a glow plug. Less than 5 minutes away.
Stage 1 igniters priming in.
GLHF again is our maiden launch. So a nominal flight would have Terran 1 reach orbit today, but our main goal is to learn as much as we can about this vehicle and demonstrate the product concept. A major milestone would be for us to reach max Q today, the point of maximum dynamic pressure.
Stage 2 is on internal power.
And the
TE cradle disengaged.
TE cradle, there we go, disengaged. You'll see that cradle arm slowly start releasing stage 2 so that the strong back can retract. And you can see the engines gimbaling there. We're performing the final thrust vector control health checks on both stages right before liftoff. You can see stage 1
is on internal power.
Engines there.
Strung back, retracting.
And now that black truss structure will retract just a few degrees to prepare for umbilical separation. There it goes.
Stage 2 TVC checkout.
As we approach T-minus 2 minutes, just a reminder, the vehicle you're looking at is 85% 3D printed. Those white clouds you see coming out of the rocket are due to the venting of the chilled gas from the vehicle into the humid air that we have here in Florida. That's why it condenses into vapor and it looks like clouds that are floating out. You'll also see the flare stack on the bottom right there. That is just used to vent out flammable gases. Next up, our range coordinator will ask the range for their final status.
Rock, report range status.
Range green.
We got confirmation. Range is green for launch.
Propellant topping closeout.
Flight computer and countdown.
Announcement on countdown, that is the LD. We've had a board and terminal count. This is a final instantaneous T0 launch window. We are going to be scrubbed for the day. Safing up the vehicle. Thanks for playing.
Our teams obviously gave it an amazing shot today, and we had high hopes for sending our Terran 1 off, but we're going to continue to take a measured approach so we can ultimately see this rocket off to max Q and beyond.
Once we have an update on the timing of our next launch attempt, we will share that via Twitter at Relativity Space. We hope you will join us again soon to see the world's first 3D printed rocket fly. I am Rachelle Aniceto.
And I'm Arwa Tizani Kelly. Thank you. See you next time.